Welcome to the viewers. Now we discuss two species models, and basically in this model we study qualitatively, not quantitatively, and just simply we study. At first, for the qualitative study, and let us consider two interacting species. With population size xt yt, and in the cases of the continuous model, and let the model equations for interacting system be of the form dx dt, that will be phi of xy, taking it equation number 1, and dy dt is equal to psi of xy, taking it equation number 2. Now we take a definition. The definition of equilibrium point. At first we have to define it. So an equilibrium point x star y star of equations 1 and 2 is the solution f of xy, that is solution of phi of xy, that is 0, and psi of xy 0. That is called an equilibrium point, and better to say that is a system of equations 1 and 2. And this equilibrium point, for the geometrical purpose, it is a phase space for geometrical viewpoint. Equilibrium point is a phase space. We discuss this later. Now here we consider the concept of linearizations. That means with the help of linearizations, it is very much useful to make a commutative matrix. It is a making a matrix form, and we discuss later, and gradually it will be clear how we use the linearization systems. So at first we linearize it and gradually clear what it is. Now stay connected with this video. So let us linearize the system of equations 1 and 2. That means these two systems, dx dt, phi of xy, dy dt, psi of xy, 1 and 2, about the equilibrium points x star y star. We linearize with this about this point. So we can write v is equal to x minus x star and w equals to y minus y star. Therefore dv dt is a x continuous function, it is constant, so 0. Dx dt and dw dt, that will be dy dt. So from equations, system of equations 1 and 2, we replace dx dt by dv dt, and phi is the function, so x will be replaced in terms of the points, equilibrium point x star and v. So x will be replaced by x star plus v, and y will be replaced by y star plus w, and dy dt, that will be replaced by dw dt psi of, then simply same as like that, x star plus v and y star plus w. So from these two we use Taylor series expansion clearly about v and w points, and it's clear about these 2 points and to equilibrium point mainly, and Taylor series variable we know already. And you consult better to in differential calculus using Taylor's series expansion. We have here, it will be phi of x star plus v and y star plus w, that will be phi of x star y star plus with v and del phi del x at the point x star y star plus with w del phi del y at the point x star y star plus eta 1. We give clarification of eta 1 next stage, and psi x star plus v y star plus w, similarly psi of x star y star plus v del psi at the function of x star y star del x plus w del psi at the function of x star y star del y plus eta 2, where eta 1, eta 2 are functions that are small deviations or perturbations, that is a small disturbances, perturbations of v and w, in the sense limit as vw tends to 0 0, eta 1 of vw by root over of v square plus w square is equal to 0, and limit vw tends to 0 0, eta 2 of vw v square plus w square is equal to 0. So this is a clarification of eta 1, eta 2. Now neglecting higher order terms, eta 1 of vw and eta 2 of VW, we have the linear system of equations that is dv dt is equal to del phi at the function of x star y star, that is we can write it as v, if we use the notation phi x at the point x star y star plus w phi y at the point x star y star, we simply use this notation because phi x is del phi del x, and dw dt, that will be v psi x at x star y star equilibrium point plus w psi y x star y star, and the coefficient taking it equation number 3 and 4. The coefficient matrix from 3 and 4, if we take it as v dot, here we write v dot and w dot, and coefficient matrix will be only this quantity, that is if we note it as it will be capital A, and that will be noted as phi x x star y star phi y x star y star psi x x star y star psi y x star y star. It is a coefficient matrix, and this matrix is known as community matrix. Of the system of equilibrium point x star y star. We find the community matrix here. Therefore, equations 3 and 4 can be written as, if we take a matrix here, v dot, that is dv dt, and w dot, that will be given as, it will be and taken as a11 a12 a21 a22 with, it will be v and w, where a11 is phi x at the point x star y star, a12 phi y at the point x star y star, a21 is psi x at the point x star y star, and a22 is psi y at the point x star y star. So the elements, all are the elements of community matrix. So in this way we can find these elements of community matrix. So we can give some of the ideas about linearization topic, and to find out the community matrix we end our discussions. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.